Good morning, everyone. Myself, Shivraj Singh, Assistant Professor in Electronics and Communication Department, and today discuss about the type of signal and its type on the subject of signal system. Signal. Firstly, discuss signal. Signal is a function that represents the variation of physical quantity with respect to one or more independent variable. It is usually time, space, etc. The basic example of the signals are like speed signal, temperature signal, ECG signal, etc. Signal may be one-dimensional or two multi-dimensional. One-dimensional signal in which function depend on a single variable. For example, audio or speech signal, temperature signal, ECG signal. Next one, multi-dimensional signal. The multi-dimensional signal are those signal in which the function depend on the two or more independent variable, like 2D signal, like just like image signal, and 3D signal, that is video signal. Next one, type of signal. There are two type of signal, continuous time signal and second one discrete time signal. First one, continuous time signal. Continuous time signal is a signal that is defined for every value of time, where time is the continuous variable. That, for example, sinusoidal signal. In this figure, we can see so that the in each time signal is defined. That means in each time interval signal has some amplitude. That means continuous time signal is has continuous nature. Next one, discrete time signal. Discrete time signal is a signal that is defined only a discrete instant of time. That means it is defined only a integer value. For this is 0 for minus 1, 1 amplitude will be 2, 8 that 2 amplitude 3 and so on. That means discrete time signal only define a particular integer. Next one, classification of signal. So continuous and discrete time signal are defined as even and odd signal, periodic and non-periodic signal, causal and non-causal signal, energy and power signal, deterministic and random signal. First one, even signal. Even signal is said to be a even signal if it is symmetrical about vertical axis, if time horizon. For this one, uh, x of t equal to x of minus t. That means if we replace the time t into minus t, that means equal response will be achieved. For example, cos signal. In this figure, we can see so that at the origin point, left side and right side are same. Next one, odd signal. Odd signal said to be a signal said to be a odd signal if it is antisymmetrical about the vertical axis. It is also called odd signal. In this case, if we put the t, a positive t replaced by minus t, then x of minus t equal to minus of x of t. Next one, periodic and non-periodic signal. Periodic signal. A signal said to be periodic if it has defined pattern and repeat itself at a regular interval. That means periodic signal repeat itself after a one complete cycle. Next one, if signal not repeat after a complete cycle, that is called non-periodic signal. In this case, 0 to t only define the signal. That means after t, it is not repeat itself. Next one, causal and non-causal signal. A signal x of t is said to be causal signal if the signal x of t is equal to 0 for t less than equal to 0. That means x of t is 0 for negative value of t, and anti-causal signal, anti-causal signal, a continuous time signal x of t is called anti-causal signal if x of t equal to 0 for t. That means it is not defined for the positive value of t. Non-causal signal, a signal which is not causal, that that is called non-causal signal. That means it is defined for positive as well as negative signal. In this figure, we can say the function x of t defined for positive value of t as well as a negative value of t. Next one, energy and power signal. So the energy signal, a signal said to be energy signal if and only if the total energy is finite. That means for energy signal, the signal energy is finite and average power of 0. Similarly, all the non-periodic signal is are the example of energy signal. And power signal, a signal said to be power signal if the average power is finite and its energy is infinite. Next one, deterministic and random signal. So deterministic signal is signal whose value are completely specified by the mathematical expression and can be exactly predicted. That means, for example, a sinusoidal signal is properly mathematically is defined. That is, it is predicted value and also called determined signal. Next one, random signal. So random is a signal whose the value cannot be predicted exactly. That means it is not represented by mathematically. For example, in communication system, if noise intrude the signal, that is random signal. Thank you.